Hi, I'm Michaela Stewart from PSSC Physics, and I'm doing the extra credit where we had to write 20 original questions for our midterms coming up, and I'll be explaining what I did, how I did it, and why I did it. Okay, in this problem, Carissa's mom made her clean the whole house before she could watch TV, and even then her mother said she couldn't. Mad, Carissa decided to throw her television out her window. Carissa's room was on the 3rd floor, 23 feet high, and she really wanted to damage the TV, so she launched it horizontally at about 17 feet. Before Carissa shattered her television on the concrete, what was its initial velocity? So to find this first, I used the equation to find the vertical time. Well, it's not really the vertical time, but I use the vertical component to find the time. That way I can plug it in to the initial horizontal velocity to find that equation. So, plugged in the values after I converted the feet to meters. 23 feet is 7.01 meters, and then the acceleration is negative 9.8 meters per second squared. So I plugged in the values to the equation position equals initial velocity plus half acceleration times time squared. Plugged in the equation, did my math, and the time was 1.2 seconds. So now I can plug it in to this equation. And I did. The horizontal velocity equals the horizontal distance over time. Plugged in the equation, and I got 4.32 meters per second. That was the velocity that the TV was launched at, horizontally. And the next problem was a complete the table one. This was based on the unit of centripetal force. Basically, I just divided the constants that I was given. That way I could know by how much it was related and proportional. And I got the answer to be, for the centripetal force times time squared, the same. And I didn't even plan it out that way, but it was. So that was pretty cool. And the constants are right here. Mass of the washers, mass of the stopper, the length of the string, which would be the radius. And the part B was to find the percent error. And to do that, you have to find the actual answer. So I just plugged in my numbers into 4 pi squared times the mass of the stopper times the radius, which is the length of the string. So plugged in the values after I changed the mass of the stopper to kilograms and multiplied it by the length of the string times 4 pi squared, and the answer I got was 0.1115 kilograms times meters, and the theoretical answer was 0.1129 kilograms times meters. So I found the percent error, which ended up being 1.26%. Next, a car from rest with an acceleration of 2 miles per second squared. A bicycle passes the car with a constant speed of 35 miles per hour. How far will the car and bicycle have traveled from the car's starting point for the car to catch up to the bicycle? So, this is kind of a multi-problem. First, you want to know the position of the car and the bicycle. So to do that, the equation is position equals initial velocity times time plus half acceleration times squared. And plugged in the values, and we don't know time, so the answer for the position is 2 miles per second squared times time squared. That's for the car. And the bike's position, same equation, initial velocity times time plus half at squared. But there was no acceleration because it was constant. So plugged in the values, and the position for the bike is 0.0097 miles per second times time. And then I realized that both the car's position and the bike's position equations are similar in the way that they have no idea what the time is. So since the answer wants to know how far have they traveled to be at the same position, then I should set them equal to be in the same position so I can know how far they traveled. So I set equal both of the equations and found out to be 0.00485 seconds was the time of how long it took for the car to catch up with the bicycle, which makes sense. It didn't even take a second. And so now we plug it into the equation that we had right here for the bike. And the answer is 4.7 times 10 negative fifths miles. Well, that's not a lot. Okay. You're walking down the street and you see a penny fall right by your foot. It's not yours because you're broke, so you look up and see a person on the roof of the building. You wonder how high from the ground the penny has dropped from, and you find out that it took 5.23 seconds to hit the ground. How high was it dropped from? Give your answer in feet. So I wrote down the constants, which was time equals 5.23 seconds, acceleration is negative 9.8 meters per second squared because the penny fell, so it would be negative. And